So we want to talk about the effect of weed density on crop yield. Actually, this is where we are going to gain some information of characterizing crop genotypes to find whether they are tolerant to weed infestation. Also, we may be able to identify problematic weeds in terms of their competitive abilities. So the research designs which have been used to study the effects of weeds on crops are as follows. Number one, we've got the additive designs. Number two, the replacement series. And number three, the addition series or response surface. Then number four, we've got the dialer design. And number five, we've got the neighborhood experiments. So we are going to go through these five approaches in examining the effect of weed density on crop yield. So we will start with the additive experiments. Now, in additive experiments, the research questions or objectives which we want to look at are number one, we want to define or we wanted to define the weed density which can justify weed control. So what is the minimum weed density which justifies weed control? Now, if we go into a field and find that there are weeds, does it mean that we should just control them? Or there's a certain number of these weed species which justifies control? Because remember, weed control can be expensive. It can draw money, which could be switched to other things. The second question is, what is the most competitive weed? We know in our fields there are a number of weed species which invade the agricultural field. Do they have a equal status in terms of competition? And one final thing which is important is crop yield loss. Now, when we have weeds in the field, what kind of weed losses, crop yield losses, do we get? Now, in these studies, we can actually employ pot studies, or even field studies can be done. Here I have got an example of an additive experiment where we have maize being grown under different densities of Rapoko grass. So you can vary the density of the weed, but maintaining the density of the crop constant. For example, here we are just having one maize plant per pot, but the number of Rapoko grass is being changed in various pots so that we can assess the impact of the weeds on maize dry matter production. You have also an example of the competition between maize and Tithonia rotundifolia on maize growth. Probably the idea was to try and determine the competitive ability of Tithonia, since it is becoming a problem with in Zimbabwe. Yeah, again, probably you can hardly see maize. This was a glass house experiment where a lot of Tithonia grew. It was a pot experiment. So I want to go into the methods. Remember, we want to determine the competitive ability of the weed. We also wanted to determine the crop yield loss. So these are the questions. We also wanted to determine the minimum weed density, which can justify weed control. So on the methods, we can vary weed density. For example, we can have 0, 2, 4, 6, 8, 10, 12 plants per pot, while crop density is held constant. For example, in this case, we are having one plant per pot. The treatments have to be replicated in an RCBD or a CRD. The data collected uh, is crop height, crop biomass, leaf area, and the weed biomass. But in most cases, we aim for crop biomass. Now we can use graphs and regression analysis to explain the data. Although tables may be used, these are usually not suitable for this kind of a study. Basically, we want to relate weed density to crop yield or crop biomass. And these are some of the relationships which are usually reported in this kind of a study. Depending on the number of treatments, in most cases, we may get a linear relationship, which is basically y equals to a plus bx. It could be a quadratic response, exponential curve, hyperbolic curve, or sigmoidal curve. In our case, we will mainly focus on 4 and 5, although sometimes 1 is usually reported because of the limited number of treatments. But 4, the hyperbolic curve and the sigmoid curve are the common relationships when you relate weed density to crop yield. Remember, you can use these relationships to determine the minimum number of weeds which can justify weed control. You can also determine the competitive ability of the weeds. You can also determine crop yield loss. Now, effect of weed density on crop yield. What is the density which justifies control of weeds in order to avoid economic yield loss. So these are some of the things which we wanted to find out. The other issue is that is it important to go in the field and do some weed counts or monitoring weed populations so that we can plan weed control programs? Is weed density the best tool for predicting crop yield loss, or there could be other methods which are easily uh, accomplished for this purpose? Is data collected from one weed species applicable to fields with mixed weeds? One of the problems with this approach is that we can only study one weed at a time, yet crop fields have got mixed weeds. Anyway, we'll explore these methodologies and see what we can do. Here, I want to show you the relationship of weed density and the crop yield. Now, this sort of relationship, where in the beginning it's sort of flat, where nothing seems to be happening, then suddenly you've got a steep slope, then it actually curves. This is known as a sigmoidal curve, which was proposed by Zimbabwe. And please note that we have got weed density on the x-axis, crop yield on the y-axis, and we have got this S-shaped graph. Alternatively, we can plot crop yield loss on the y-axis and weed density on the x-axis. And when we do that, we also get a sigmoid curve according to Zimbabwe. Now, you can notice that somewhere here, the losses are low, but versus weed density here. Now, as we increase weed density, we slightly increase crop yield loss. But we reach a point where the loss is very high. At that turning point, we can call that the weed control threshold. So this could be the minimum number of weeds or the minimum density which uh, which determines whether weed control has to be done or not. Because if we do weed control at this juncture, we can avoid this big loss. And this graph can demonstrate this clearly. The sigmoid curve, which was proposed by Zimdal. So what you are saying is that you can use these treatments as the x-axis and plot them against crop biomass. And this is what you can get. But if you use your control to estimate the crop yield loss, you get a graph like this one. And normally this is the tool which is used. This sort of a graph, which is the sigmoid curve. But a scientist known as Cousins proposed that as long as you have weeds in the field, there is no delay in crop yield loss. In fact, there's a sharp decrease in crop yield loss. Then it will start to level off later on as you increase the weed density. Just notice this. This one is saying that there's a delay in loss according to Zimdal. It's a delay, you don't get a sharp decrease. So if it was according to Cousins, we will have a very sharp decrease. So there are two different approaches. So as long as there are weeds, they should be removed according to this graph. Now let us look at the crop yield loss. Now, according to this graph by Cousins, as long as there are weeds, there's loss. So there's no delay here. So you have this decrease. Then it levels off somewhere here. So we can identify two areas in Cousins' graph. The first point which we can identify is this one, the slope, which is represented by I. And we have also the maximum crop yield loss, which is represented by A. So for the weed, we will have two indices, I and A. So I and A could measure competitive ability of a weed. If we repeat this experiment with several weeds, drawing these several graphs, we end up with several values, each weed having unique values of I and A. And we can simply compare these values and they come up with the most competitive wheat. Now, this curve can actually be represented by an equation which was proposed by Cousins in 1985. What it says is that yield loss is equal to the slope. This is the slope multiplied by dW, which is the density. This is the density, width density, dW. I did not write dW here, but this will be dW, width density. So you've got the slope and density dW. We will see where we are going to put A in that equation. So that equation has got three elements of this graph: A, I, and width density, which is dW. So yield loss is equal to the slope, which is I, multiplied by dw divided by 1 plus, or in brackets, I times dw divided by A. So basically, these elements, we get them from the graph. What we have just done is just to add 1 into the equation. So YL is the yield loss, dw is the width density, I is the slope, A is the maximum yield loss. So you can use this graph to determine the maximum yield loss, which is A. Now, this result was obtained by one of the students who was studying Tithonia and maize competition. You can see he applied the Cousins approach, and he could draw this graph, which is, in fact, the name of this graph is is this last one. It, it is this one, hyperbolic curve. So this one is a hyperbolic curve. So this is what what this student got, and he could estimate A is 64%. That was the maximum yield loss when Tithonia rotundifolia was competing with maize, and this was the slope. So 64% and 1.4 or 5, if you like, are the parameters for competitive ability. There was also a study done by Chivinge and Rukuni in 1989 where they varied the oxalic density from 0 to 6, and this is the mean yield loss. Now, should we plot the percentage yield loss of the same data, we get what Cousins was suggesting, the hyperbolic curve, which has got two areas, the slope and the maximum yield loss. Again, this is the data with the Tithonia rotundifolia density and the percentage yield loss in maize. You get an approximately hyperbolic curve. By the way, we can use a sigma plot to draw these graphs and possibly to work out these equations. Now, I want to move back to this equation. Now, this equation can be accurate in predicting crop yield loss when the crop and the wheat are emerging at the same time. But if you have weeds emerging ahead of the crop, this equation will not be able to predict accurately the loss in the crop due to weeds. So Cousins had to come and modify this equation. In fact, He only came and adjusted one and substituted it with the natural logarithms. So Cousins had to remove one from the equation and put e, which is natural logarithm, which was raised to the power of c, which is a constant. This is the rate of which I decreases, I representing the slope. But what is more important, he added the time of weed seedling emergence to this equation, which is represented by T. So according to Cousins, yield loss is now equivalent to IDW divided by E raised to the power C times T plus IDW over A. Now, when he had done that, then the equation became accurate in predicting crop yield loss when infested with weeds. Here I've got a table of data pulled across various studies which were done using the same approach, varying weed density across various crops. And you can see the authors who did these experiments. These are the crops. These are the weeds which were studied, and we have A and I values. Probably to make it easy, we may just focus on A and see which weeds are very competitive. Those weeds with low percentages are less competitive. Those with the high A values are the most competitive weeds. And of course, depending on the crops. So in some countries, they've got data for various weeds. They know how they compete in various crops. They can employ computer programs to determine when to come and weed or when to come and spray or not to spray, using a lot of data from these competition studies. In contrast, this is in contrast to us, where we have a few data on weed crop competition. We don't even have knowledge about the A and I values of our weeds, which makes planning weed control problematic. Any questions at this juncture? Hello?
I've got the question.
Yes.
The first equation on Cousins approach that the first one is now 1 plus. You said it was adjusted to use the logarithm so that it's better for the different kinds of creative of the weight. What is the adjustment? It's the same cousin.
Yes, yes, yes.
Okay.
Right. You'll find that if weeds are emerging with the crop, His first equation where there's a 1, it's fine.
Okay.
But if you go to conservation agriculture, normally weeds go ahead of the crop. They emerge ahead of the crop. In Pfumvudza, Cousin's equation won't work there
Okay.
unless we have adjusted it. But the adjusted one, I mean, it's quite well. It can work very well in Pfumvudza, where we are doing
Okay.
reduced tillage.
Okay. Thank you so much.
But even then, there are some people who still think that using those equations, is not, there are other better methods. And we are going straight into them now. Instead of counting weeds, somebody, you remember I said using that approach of weed density, you will need to study one weed at a time. You can't put various weeds and study them simultaneously. Another problem is that if you study one weed at a time, what will happen when they are in a mixture? Are we having accurate information, etc., etc.? So, Croft and Spitters thought probably the best approach could be don't worry about different weeds. Just focus on leaf area index of the weed. So they came up with what is known as the relative leaf area. So you go into a field, you measure the leaf area of the weeds or of the wheat and calculate the leaf area index, which is represented by LAIW. You also measure the leaf area index of the crop. Now, in order to get relative leaf area, you simply divide leaf area index of the weed divided by leaf area index of the crop plus leaf area index of the weed. Now, this LW, leaf area, relative leaf area, you substitute it on the graph. Instead of writing weed density, you put in leaf area like this. So LW becomes here, and your crop yield remains there. But what only changes is the name of your slope because it's now a different thing. Although talking about the same thing, it's the Q. You have a Q value and the A value. These become the parameters of measuring competitive ability of the wheats. And then even this may change. The approach in estimating yield loss. Yield loss becomes now Q multiplied by LW, which is relative leaf area, divided by 1 plus, or in brackets, Q over A minus 1 in brackets multiplied by LW. Then they said, okay, this can actually give you crop yield loss, but it can overcome probably the problem of dealing with the one weed at a time. Even if you wanted to start the one weed at a time, you can still do so, but it gives you room for flexibility. You can involve several weeds if you want. And of course, this is the equation they proposed Y yield loss equals to Q multiplied by LW, everything divided by 1 plus, or in brackets, Q over A minus 1 multiplied by LW. So Y is the yield loss. LW is the leaf area as a fraction of total crop plus weed leaf area. Then Q becomes the slope or relative damage coefficient. They gave it a name, relative damage coefficient. Then A is also remains A, the maximum yield loss. Then they said we can even simplify it further. Probably measuring leaf area may also become cumbersome. Probably what we just need to do is to estimate what is known as the relative cover. Now, relative cover is the area covered by the weed divided by the area covered by the weed plus the area covered by the crop. This you can actually do by eye estimation. You can just go into a field and say, do I have 30% weed cover, 40, 50, 60, 100, and so on, according to your assessment. Probably with practice, this becomes accurate. We experimented with a group of students who were measuring relative cover and at the same time weed density. The results were the same. So in the graph, you now plot RC, which is the relative cover, on the on the x-axis, RC. Crop yield loss remains crop yield loss. But what happens to this equation? You just remove area and put RC in the same equation. Yield loss is equal to Q times RC divided by 1 plus, or in brackets, Q over A minus 1 times the RC. It will give you the A value and the Q values, which give us an estimate of the competitive ability of the weed, of one weed or several weeds. So again, this is the equation: yield loss according to Spitters, according to Croft and the Spitters, Q times relative cover divided by 1 plus, or in brackets, Q over A minus 1 multiplied by RC. You may want to read the Cousins' paper. I think I'm going to post it on your platform. It's a simple model relating yield loss to weed density. Yeah, you can read Roger Cousins' paper, and it will enable you to understand what I was trying to put across. Then you can also read another approach by Croft and Spitters. They also say it's a simple model. I don't know whether it's actually very simple. So it's a simple model of crop loss by weed competition from early uh, observations of relative leaf area of weeds. So there are two contrasting papers, one talking about density, the other one about leaf area. Then there's a typical field paper. I think this experiment was done in rice in Mexico. Uh, whether it uses density or leaf area, you just read about it. What is interesting is that it deals with so many weeds in a typical field condition. Then there's this one again by Croft, which is talking about these issues. This looks like a review paper. Just get hold of these papers. Maybe I will post them on your platform so that you don't have to wander around searching for them. The other paper is by Chivinge and Rukuni, 1959. And we also have this paper, I think it's also interesting, by Ali et al., 2013. I may have to post some of these reading materials to you so that you reinforce your understanding on these issues. What are the disadvantages of additive designs? One of the disadvantages is that crop biomass may vary with the species proportion and density. Now, what we mean is that as you are increasing density, you are also increasing the proportions because weed species may tend to compete amongst themselves in the intra-specific competition. Its impact is not actually evaluated using this approach. So there tends to be some confounding. The effect of the weeds themselves on, on the weeds may not be observed. The competitiveness of the crop is not determined. We may not know the competitiveness of the crop, but sometimes we can, modify this experiment if we are going to indirectly. We can use various cultivars and see whether the competitive abilities of the weeds are changing. Third, it does not separate intra and interspecific competition, like what I said, because we are dealing with these proportions. Okay, this was one of the experiments where Tithonia rotundifolia density was varied in a maize crop. This was here at UZ. You can see a student there observing the experiment with additive design. Here you can see a lot of Tithonia. You can hardly see the maize crop. Here is the Tithonia in Murewa in the fields. That's why we are motivated to study its effects in maize crops, because it's now tending to invade the agricultural fields. Now, about weed control thresholds in Southern Africa, or even in Africa for that matter, there is very little research. Actually, very little research has been done on weed control thresholds in Southern Africa. There are very few papers. There's also an issue on the first flush of weeds in summer, which appears to exceed weed control thresholds. Now, depending on how you are going to plant your crop, early planted maize or early planted crops are subjected to the first flush of weeds. And it's likely that they can exceed weed control thresholds. Therefore, weed control is always necessary. But there could be farmers, on conventional tillage who come in and plow after the first flush of weeds, although there could be a penalty in delayed planting. These second flush of weeds appear not to be competitive, and therefore the density may be below what we may call the weed control threshold. It is possible. Now, weed control thresholds in Zimbabwe, in winter cereals, in most cases, weed seedling emergence appears to be below weed control thresholds. In other words, farmers may actually uh, avoid weed control in wheat. They can get away with it in wheat because probably the weed control thresholds are not reached, especially in the high veld. Probably it's something to do with the issue of frost, which may kill some of these weed species. So after this one, I will stop for a bit and get probably feedback from you.